Okay, so hello and welcome to our eScience tutorial on deploying science gateways with Apache Airavata. My name is Marcus Christie, and I'm joined here today with Arama Abesingi, and Marlon, I think will be joining us later, but then also Suresh Maru from our team is here. And we're part of the Cyber Infrastructure Integration Research Center at IU. And yeah, that's our email at the bottom. So I just want to give a brief kind of a high level 10,000 foot view overview of what it is that we do and the software that we've been developing. So the primary project we work on, software project that we work on, is Apache Airavata. And Airavata is it's middleware for managing executions of scientific application code and essentially everything else that goes with that. Part of that is managing users, authenticating users, authorizing users to what they have access to do. Part of that is dealing with moving data. Key workflow there is that users will specify certain data sets as inputs to a scientific application run. And so Airavata will handle staging the data in to a cluster, and after the application finishes running, it will transfer the data back out. And Airavata keeps track of all this metadata about the execution of the application code, when it was run, where it was run, where the data was generated, where the copies of the data now that it's been completed. And that goes some way to making the application runs reproducible because of all the metadata that Airavata records. Airavata works with, because it has I guess I would say because it has a shared nothing architecture, it can integrate with university computing resources, Exceed, cloud resources, pretty much whatever you want to integrate into a science gateway. So I won't say I won't say too much about this slide because I've got one in my presentation as well. But here's a high level overview of kind of Apache Airavata, which is in the middle here. And so we've got the compute resources on the right, and on the left, we've got science gateways that are making use of Airavata. So Airavata provides a lot of services. A lot of the stuff I was mentioning on the previous slide, managing executions, workflows of executions, managing the metadata about scientific application code executions, keeping track of where input and output files are, managing user access. But all this stuff that Airavata does, it does kind of under the covers, because what it exposes is this API that is that you can access in a secure and authenticated fashion, and it's authorized and everything. Let's see. Okay. I'm sorry. Give me just a minute. PowerPoint is trying to. Oh. Oh no. Does anybody know how to turn off subtitles?
I think right now they are turned off. If you start again the presentation with this slide,
Okay.
I guess. Yeah, they're
Oh,
off.
okay. Nice. Yeah, so Airavata provides a single API that brokers request to the various Airavata subsystems. And it's this API that science gateways use to build their user interfaces and integrate with Airavata. So for this tutorial, what we'll be doing is working kind of on this left side of this diagram, deploying and creating and modifying a science gateway that's making use of the Airavata API. So we'll cover how to use a turnkey Django gateway to work with the Airavata middleware. So we have a Airavata, what we call the Airavata Django Portal, which is fully integrated with the Airavata API. You could certainly develop your own user interface, or it could be a command line application or some sort of automation that uses the Airavata API. But what we find is that a lot of science gateways want a starting point, and that's what we have with the Airavata Django Portal. We're going to look at how to customize the look and feel. So we'll go from, what do you get out of the box with this Airavata Django Portal, and how do you take it to the next step as far as customizing it for the needs of your users of your science gateway. And we'll look at how to create custom applications in a local Django installation that we'll be setting up. So, these custom applications then are where you can start with the Airavata Django Portal, but then create user interfaces that are unique and that provide what your users want from your science gateway, and that integrate with maybe some other codes that you've developed for, say, creating input files to your application codes, or for visualizing outputs. So we've got this link for the tutorial. This is a little bit wrong here. This is the perk one, although it's basically the same agenda. Okay, so why would you use Apache Airavata? So one thing is that we have Apache Airavata. It's an open source project. It's an Apache project. So in theory, you could run it yourself, but you don't have to. We have a project called SciGAP, where we provide a hosting service for running Apache Airavata and hosting an Airavata Django Portal instance for you. So then what that means is all you really need to do is bring your resources, your scientific applications, and we can set you up with a turnkey gateway very quickly. And then we can go forward by building on that to create highly customized user interfaces that make sense for your user community. So how would you work with us if you want to work with us? So for Exceed gateways, you can request extended collaborative support services through January 2022. For non-Exceed gateways, we can give you a free trial for 1 month. And you can also work with us through the Science Gateways Community Institute. Okay, so let me let me stop sharing and see if there are any questions about those slides there. Okay, let me go back to our agenda. Okay, so let me give a presentation here. Let me go into, let's see. Okay, I want to talk a little bit more about the Airavata Django Portal. So the Django Portal, so we can conceive of it as not just a user interface that uses the Airavata API, but as a platform on which science gateways can take it and develop their own custom user interfaces on top of it and customize the user interfaces that are provided by the Django Portal. So yeah, so we've seen this slide in the previous presentation. I'm not sure, actually, I think I covered everything that I wanted to say there. The Django Portal sits here. It's basically a science gateway over here, and it uses the Airavata API. I think that's all I wanted to see. I'll get into like the architecture of the Django Portal a little bit later. So how do you use the Airavata API? What kind of API is it? So what we use is a project called Thrift. It's another Apache project. And Thrift has an interface. It's an interface definition language that allows you to define your API as a RPC type API. You define all of the methods that are available on your service. You define what are the inputs and what are the outputs, and so you can create your own kind of custom data models for inputs and outputs. And this interface definition language is not what do you want to say? It's not language specific. It's language agnostic, programming language agnostic. And so what you can do is with Thrift, you can generate stub code in multiple different languages. So that's really nice because that allows you to write an integration with the Airavata API and pretty much any language you can think of. So ones that we've used quite a bit have been PHP, Java, C++, and Python. The Airavata Django Portal, because it's using the Python Django web framework, it makes use of the Python API stubs that are generated from the thrift description of the Airavata API. So I just wanted to cover a little bit of kind of the history of how we've approached the user interface side of things and in the Airavata project. So initially, the idea was, we'll create the API, make it possible to integrate that into all sorts of different UI frameworks because of this, the fact that Thrift can generate stubs in multiple languages, and then let the community develop the user interface or take their existing user interfaces and integrate with the Airavata API. And that worked to a certain extent, but we find that what we found was a lot of science gateways wanted something to start with. There are a lot of researchers who want a science gateway and they don't have anything yet, but they also don't want to build a UI from scratch. So the next phase in how Airavata approached the user interface is we developed a reference implementation using PHP. This was nice. This gave folks who wanted to use Airavata and spin up a science gateway, a turnkey solution. This PHP reference implementation, it exposed all of the functionality in the Airavata API. So it was quite useful for us to be able to demonstrate, here are these different things you can do with Airavata. It also served as, it really did serve as a reference implementation in that it showed how you would use the API in a user interface. The main problem with this PHP reference implementation is that it wasn't very easy to customize. So every one of these gateways looked and behaved basically the same. There were some attempts by some gateways to customize the code, but that required is essentially creating a fork of the code, which was then not easy to maintain. So in our current approach, which we're going to get into with the tutorial, what we've tried to do is create a reference implementation that, that's a turnkey solution, but one that you can also build onto and customize in a way that doesn't require you to, fork the code, but in a way that's fully supported, and that has some APIs that can be used to make that a little bit easier. So we've got this Airavata Django portal that we can create and set up for a science gateway that exposes all this functionality, but then you can also develop, as a gateway developer, you can develop plugins that enhance or add to the functionality of the Airavata Django portal. So here's a high-level diagram of the architecture. This blue circle down here represents the Airavata API. And, well, yeah, it essentially represents Airavata. And this cloud here, all the compute and storage resources and such. So the Airavata, the Django portal web server has a Airavata API client. Essentially, that's the Python client that's generated from the thrift description of the Airavata API. And while we developed to make it easier for the front end in these Django portal web pages to communicate with the Airavata API, we created a REST API bridge. So when a user logs into the Airavata Django portal, they get back a page that has some dynamic front-end code. We're using Vue.js for the dynamic UI code. And this code can then make REST API calls back to the Django web server, which then proxy to the Airavata API client and then to the Airavata API. So I guess one thing I'd like to point out is that when you develop, and we'll see this in the tutorial, when you develop custom applications in the Airavata Django portal, you can also make use of the REST API. So we've come up with 3 different ways of customizing the Airavata Django portal. One is to do input editor customization. So by default, without adding any additional configuration, when you define your scientific application code and what sort of inputs it has, there are essentially 2 types. There's string inputs and there are file inputs. For a string input, you get this text input, a pretty plain text input type user interface. For file uploads, you get a user interface where you can select a file from storage, or you can upload a brand new file. And especially for the string inputs, sometimes you quite often have some constraints or some additional requirements that you would like to enforce by the UI. So one thing you can do with customizing these application inputs is you can change the user interface for them. So you can elect to use radio buttons if you have a small set of single valued values for an input. You can use checkboxes as well. There's drop downs. You can specify text area, etc. The other thing you can do with these string inputs is you can define validations. And we'll see more of that within the tutorial. And the user gets some nice feedback about what exactly is invalid with with whatever they've provided. The other thing, so that's kind of one side of it, is the user comes to the portal and they provide some inputs to one of the scientific application codes. And then the application runs and it generates some output files. And by default, the user in the Django portal can download those files. But if you want to, you can provide visualizations or other sorts of analysis of those output files right in the Airavata Django portal. So you can do this by creating what we call an output view provider. And an output view provider essentially has some metadata and a generate data function. And this generate data function takes the output file as an input, and here's where you write some code in here to generate an image or a chart or some sort of analysis or visualization of that output file. And then you return something that, like for an image, you would return a byte array of that image. And we have several different output view types that are supported, and it's pretty easy to add additional ones. And here's just some screenshots of different types of output view providers we've implemented with different science gateways. So here's one where this one's pretty simple. It just generates a link with some information in it to another tool within the gateway that provides a visualization. And this one we'll be looking at, we'll develop this as part of the tutorial. This is one where we develop an image that's a matplotlib chart with some data from the output file. So we've talked about the first two ways to customize the user interface in the Airavata Django portal, customizing how users provide inputs to scientific applications and customizing how users interact with the outputs of these application codes. So the third way is to create a completely new and custom user interface. So you can do this by creating a custom Django app. And I'll talk a little bit more in the tutorial about what these are, but you can think of a Django app as a plugin. So that's the Django Web Framework has this architecture that allows adding additional views and functionality to Django via this app framework. So when would you reach for creating a custom Django app? And somewhat based on our experience and what we've seen with other science gateways, one reason to do that is to provide more intuitive tools for the construction of input files on the user's behalf. So a lot of scientific application codes require input files, and they require those files to be created in a specific way. They have a specific format, and some of those are quite complicated to create for someone who is not used to that application code. It could be a researcher who understands the science, understands the techniques, but they don't know that particular file format or what the application code itself really is expecting. So we have I'll go into this example a little bit more later at the end of the tutorial, but here's an example. This is in the SIM-CCS gateway. CCS stands for carbon capture and sequestration. And here's where you're trying to formulate a problem and looking for a solution to how to store, or sorry, how to capture and then store a certain amount of CO2 coming out of these various different sources, and then putting it into the ground or something. So what we did is we created a map-based tool that allows users to pick, by clicking on or by drawing a box around the different sources and the different sinks that they want to use and setting up their problem. And there's a user interface where they can plug in the parameters for the optimization problem that they want to solve. And when they click submit, this custom Django app actually integrates with some code that already does this, but it generates the input file that the user needs to run the optimization code. So this is a much more intuitive type of user interface than for users who maybe they understand how they understand the science behind carbon dioxide storage and sequestration, but they don't understand this particular optimization code. So that's one. Oops, clicked on that. So that's one reason to reach for this custom Django app approach. The other one is to have a way to query and visualize output results, especially when you want to look at the results of multiple files. So we looked at, there's a facility for creating a custom output view for output files in the Django portal, but that's kind of on an execution by execution basis. So if you want to look at, you've run a bunch of runs of a scientific application code, you want to look at, kind of want to aggregate the results from all those and visualize those. That's where you would, you'd want to use a custom Django app. This does require substantial web development skills, and the process tends to look like you want to start with figuring out what you want the UI to be, and so we're big proponents of enlisting the services of a UX designer who will help you through the process of figuring out and working with you and your users, figuring out what sort of user interfaces will work best for solving the kind of problems that you want to solve in your gateway. And then once you have those mockups, you can start integrating those with the Django Airavata JavaScript APIs, which work with that REST API bridge. So that's how you can then start integrating the Airavata API into these web mockups. And the other thing you can do is you can look at, what sort of tools do you have, and you can create Python-based Django web services that wrap those tools. Okay, so for this tutorial, we'll look at a few things here in the process. So like if you wanted to have us host a Airavata-based science gateway for you, the process would be you would register. I mean, at a high level, the process is you'd register for a gateway tenant, and we could create that turnkey Airavata Django portal for you, deploy it, get that all set up. Then you would go in and start adding in your application codes, adding in your compute resources, etc. Kind of get it all set up. get it to the point where you can go into your Science Gateway and start running some executions and downloading the results. So that's getting you to here's what the turnkey solution provides out of the box step. The tutorial is going to primarily be focused on, okay, what comes next? And what comes next is, you've explored what you can do with the Airavata Django Portal kind of out of the box. And now you want to start customizing it and making it more useful or user-friendly for your particular users. So that's kind of where we're going to be focused on for the tutorial. Let me take a look at my time here. So just a quick overview. We're going to exercise that kind of out-of-the-box functionality in the portal by submitting a computational experiment using a computational chemistry code called Gaussian. Then we'll go through those 3 ways of customizing the Airavata Django portal that I talked about before. Customizing the how the inputs are defined for the application, and then we'll create a custom output viewer that generates a matplotlib chart and display that in the portal. And then we'll create a custom Django, a very simple custom Django app that is designed to show you how the thing is structured and where everything goes. And I think I'm going to go ahead and stop there. I want to look at my time and see. Yeah, so I think we should probably move on to the hands-on portion. So let me check and see, are there any questions at this point? Okay, well, if there are, let me pop this up here. If you have any questions, please feel free to just interrupt. I think we have a small audience today, so there's no need to be shy. So just feel free to unmute yourself and ask a question if any questions come up, and or you could use the chat as well. Okay, so let's go. Let me make sure we're all here. So what I did again in Whova for this session, and I hope we can find the session in here. If you scroll to the bottom, there's this link for tutorial slides. And these tutorial slides, it just has a link to our wiki page. And then the second link here, this agenda, that's where we are now. So let me go back over here. So let me close some of these. So we're on this agenda, and then in the agenda, and I'll put this in the chat too. We're going to go to the custom UI tutorial. Actually, let me cover some stuff at the beginning of it. So let me put this, I'll put this into the chat. So this custom UI tutorial, it's part of the documentation that we've created for the Airavata Django portal, and it's always here. And you could go through this whenever, and you could go through this when you get if we set up a Airavata Django portal instance for you, you could run through this tutorial to kind of familiarize yourself with the how you could customize the UI in your Django portal. So the main thing that we need for this tutorial, the main things are, I mean, you need a text editor. I'm assuming you have a text editor of some kind. If you're looking for a recommendation, I recommend Visual Studio Code. We need Python. The latest Python is a good one to get if you don't have Python. 3.6 through 3.9 should work just fine, but I would recommend the latest Python. You'll need Git to check out some code. And then the other thing is Docker Desktop. So we'll be running a local instance of the Airavata Django portal, and we'll be using Docker to do that. And that's primarily to make it easier to get set up because it has all the dependencies and everything. Sometimes what we found is that some tutorial participants aren't able to get Docker installed. So if you don't have Docker installed, or you can install it, there are instructions on how to run the code directly on your laptop instead of inside of Docker. But for that, you would need some additional dependencies. If you don't have Docker installed, I would suggest that you go ahead and download that now. We won't get to it for a bit, but it's kind of a big download. So if you want to get started with downloading and installing Docker Desktop, that would be a good thing to do now. And there are notes here about how to really how to verify these different dependencies. But we'll come back to that. If you have any issues with any of these, we can talk about that more at the break. I'm going to go ahead and skip on down to the hands-on portion here. So let's see, I'm right here now. I'm going to drop this link in the chat. Okay, so we're going to log into Test Drive. So we've got this Science Gateway, this Airavata Django portal deployment called Test Drive, and it's kind of our gateway. It's kind of a demo gateway for playing around with the different things that are available through the Airavata API and the Airavata Django portal. So what you want to do is there's this link here to log into Test Drive. So I'm going to open this up in a new tab. And you have a couple of different options here. One is to sign in via, there's a service called CI Logon, which integrates with several different institutions' existing authentication systems. So if I click on this, and it remembers that last time I logged in, I used Indiana University, but I can search for another university. I can also, if you don't find your university, there's also Google There's also GitHub. And what's the other one? What can I think of it? Nah, there's another one that you might have an account on. One called? Oh, anyways, it'll come to me at some point. So yeah, but this is the way we recommend that you log in. You find an existing identity provider that you already have an account with. So I'm going to go ahead and do that. Okay, so when I log in, I see, actually, let me undo this so mine looks maybe a bit more like yours. So when I log in, I see a dashboard with some applications that I can run. On the right-hand side, I see a short list of my most recent executions, or what we call, in the Airavata, we call those experiments. When you log in for the first time, you'll see a message at the top saying that you need to be given access before you can run in any of these applications, and these will all be grayed out. So Arima, I think, will be helping get access to people who need it. But let me log back out, and I wanted to go back to the login page. If for some reason you weren't able to log in with an existing account that you already have, you can create an account by coming up with a username and password. You can just click create account here, and there's a form to fill out. You will need to verify your email address. And the thing I'll point out there is, if you go through this creating your own account, you want to make sure you check your spam or your junk folder. Sometimes those emails that are the email that we send to verify your email address, sometimes they end up in the spam or junk folder. So let me log back in. Actually, I'm going to log in with my other account. So I've got a username and password one too. Go ahead and log in with that. I see pretty much the same thing. Okay, so now that we're logged in, so I'm assuming that went well for everyone. If you had trouble logging in, just unmute yourself and let me know. But I'm going to go ahead and keep moving on. So the first thing we're going to do is submit a Gaussian 16 job. So for that, from this dashboard, what we want to do is scroll down. Oh, and I guess I should say, once you've been given access, all you need to do is reload the page. So you just go here, reload the page, and you should see some of these applications not disabled. Some of these are disabled. But, so what you want to do is scroll down to Gaussian 16. Actually, I'm just gonna mark this one as favorite again. So I just clicked on that little star to mark it as a favorite. So I'm going to click on this guy, and so now I'm going to create a new experiment, which again is the Airavata nomenclature for an execution of a scientific application code. So I can give it a name. By default, it just uses the name of the application and the current time. I could give it a description, and I can change I can organize all these experiments and projects. I'm just going to leave those as the defaults. This Gaussian application just has one input, one file input. And so if I go back to the tutorial, we've got a file that you can use as an input file. I'm going to download this one. So I've downloaded to my downloads folder. So let me browse to that. There it is. Okay, so again, what I did is I downloaded this file from the tutorial page, and then I uploaded it again in my create experiment page for Gaussian 16. So that's the input to our application. Then we have some additional things, some settings around where we want the application to run and what account do we want it to be charged to. So the allocation is essentially the account that we want it charged to. So we'll just leave that as the default. That should be what you see by default, but if not, then select default. The compute resource we're going to use is Expanse, and we'll just leave these as the default here, but we could change. In general, users can change like what queue on the compute resource the job submitted to, and the node count and core count, etc. So I'm just going to hide those. We'll just leave those as the default. So the only thing we really changed here was we uploaded this input file. And I'm going to click Save and Launch. So this will save the experiment information that we created and then launch it. Again, that's through the Airavata API. So the Airavata API is now handed this experiment execution request off to the Airavata execution subsystem, which uses Apache Helix for managing the execution workflows. So now, so after I clicked Save and Launch, we go to the experiment summary page, and this shows all the information for the experiment from what we just specified for it, and then it tells us the status of the experiment, and it keeps updating as the experiment is executing. So now what it's telling me is that it's executing. It gives me some job information, so it's submitted it to a queue, and it's already active. So we've got a reservation on Expanse, so these are going in pretty quickly. This will take a few minutes to run, so I'm going to go ahead and continue on, and we'll come back to this and look at the output file that gets generated. But let's see here. Yeah, we'll come back to this later, so it'll take a few minutes to run. Okay, so now we're on to, let me check the agenda and see how we're doing on time. Okay, we're doing well. Okay. Actually, let me stop and just check with you all. Was everyone able to, or did anybody have any problem getting logged in, getting access, and being able to run Gaussian 16? Okay, cool. Let's continue on. So I'm going to drop this link, and you don't have to use this link, but if you want to jump to the part of the tutorial where we're at now, I just dropped that link into the chat. Okay, so now what we're going to do is we're going to play around with creating an application user interface and customizing the inputs. So this is kind of the work of the typically like the gateway admin, registering scientific application codes that are available within that science gateway. And what we'll be doing is we'll be using, we'll essentially be defining the interface for one of the applications that one of the science gateways that we worked with developed. So there's this LSU, there's a computational systems biology group, and they have a eScience drug binding site detection software. So we're going to just define the application interface for specifying the inputs to this eScience application, and then customize that. So what I'm going to do is in test drive, the first thing I want to do is switch from the workspace where I've been. So the workspace has, your experiments, your projects, your data. So I want to switch over to settings. I clicked on settings. And the first place where I land is the application catalog. So this looks a lot like the dashboard, but here is where we define or edit the application descriptions for the scientific application codes that are available in the Science Gateway. So let's see, go back to the tutorial. What we'll do is we'll click on the new application button here at the top of the application catalog. And we get a form to create a new application. So there are three parts to this. One are the kind of metadata details. And then there's the interface where we define the inputs and outputs, and the deployments where we can add different compute resources where this application is deployed. So we'll start by adding a name for our application, and let me see. So what I recommend you do is call this eScience, and then dash, and then whatever your username is, just to distinguish it from other tutorial participants. So I'm going to call mine eScience-Marcus, and I'll click save. So once it creates that, then these interface and deployment tabs are activated. So now I can go to the interface tab. Let me see here. So we're going to add 4 inputs, and these inputs, so I guess I should stop a little bit and explain a bit more about what these inputs are. So one thing we can do, let me think here. Okay, let me digress a little bit. I'm going to open up a new tab over here. Let me go to experiment statistics. This is kind of the administrator's dashboard for seeing what's running in the gateway. So what I want to do is I want to find the Gaussian run I just did. Oh, it's completed now. So if I click on view details, I can see a lot of the details that I can see from the experiment summary page, but I can see some additional kind of low-level details about this execution. And one of the things I can see is the job script that was generated by Airavata and submitted to the compute resource. And some of these things are, so Airavata has a template for how to create a job script for Slurm. And so a lot of this stuff comes from that template. Some of these things come from information in the application deployment. So specific commands to run pre-job. And then you get down to the job or the application itself, running the application itself. And so this line here, and it's very simple because Gaussian only has one input, but essentially here, the path to the executable is in the job script, and then any inputs to that application then get listed after it. So it's essentially the point I'm trying to make is that with the application inputs, what we're defining is how to build up essentially this command line here that will end up going into the job script. So for this eFindSite application, there are 4 command line inputs. And we'll define each of those one at a time. So for this first one, so here I'm back on my eFindSite, eFindSite Marcus. I'm under the interface tab. Yours will be eFindSite whatever, whatever your username is. So under input fields, I'll click add application input. And then for name, let me go back. I kind of have to flip back and forth between the tutorial tab and the portal. For the name, I'll give it as target ID. And then the type of string, which is the default. And then the application argument. So this is what we want Airavata to put on that command line that it builds up in the job script. So it's going to use -I and then whatever value the user provides for the target ID. So user-friendly description, this is just help text. So we'll copy that and put that down here in this user-friendly description field. And then a couple other things here. This one is required, so the user has to provide something. And we want it to be added to the command line. Sometimes you have inputs that are input files that are just in the current directory, but they don't actually get added to the command line in the job script. So there's that, and I have a screenshot here of what it should all look like once you filled it out. And mine, let me double check, mine looks pretty good. Okay, so that's the first one of 4. We've got 3 more to do, and I've just kind of summarized it in this table here. So I'm just going to go ahead and continue. What I'll do is I'll click add application input again, and then I'll add target structure. Now this one is type URI, which is how, so Airavata uses URIs to reference files. So essentially the target structure is the way the user interacts with it is the user will have to provide a file, either uploading or selecting a file for a target structure. A different application argument, -S. And this one is required as well. And it'll be added to the command line in the job script. Okay, so let's add another. Click add application input. And we'll add another one called screening libraries. And this one's string, and -L is the application argument. And this one's not required, which is the default. But it does, if it is specified, it does need to be added to the command line. And okay, then our last one, click add application input again. And this last one is named visualization scripts. And the application argument is -V. And it's not required, but if the user specifies something, we need to put it on the command line. Okay, so that's it. Let's see, what else do we have here? Okay, so those are our 4 inputs. Now we can go ahead and click save. Okay, that all got saved successfully. Okay, so we're not actually going to deploy this code, or we're not going to run it, but in the Airavata Django Portal, an application has to have a deployment for the user to be able to invoke it. And that's part of the reason why you probably saw, like on the dashboard, some of the applications were grayed out and you're not able to click on those. So what we're going to do is just create a fake deployment so that we can play around with the user interface for this. So for that, I'm going to go to the deployments tab, and I'll click new deployment. And we have a virtual cluster on Jetstream, this example VC. And so I'm going to select that as the compute resource. Okay, so now we have a form. So this is where we define the deployment. And this is basically everything here goes into that job script that we were looking at earlier. So this is where you kind of customize what needs to go into the job script for this application to run on a particular compute resource. And there's a lot of stuff here, but the only thing that is required is this executable path. And it doesn't really matter what you provide here. I'm just going to put in /user/bin/true. Again, we're not actually going to run this, so it doesn't matter what goes in there. So I'm just going to put in user bin true, and now I can click save. Okay, so now I can go back to, so at the top of the screen, this main menu up here, I'm going to switch from settings, where I currently am, back to the workspace. Okay, so now I should see, if I scroll down, I should see my eFindSite application, and I can, because I defined a deployment for it, I can click on it. And when I do that, now I get this in my application configuration section. I've got the 4 application inputs: target ID, target structure, screening libraries, and visualization scripts. Okay, so that's nice, but there, and if you know what needs to go into each of these fields, this would, and you have the application actually deployed, this would work, and we could submit the job. But this makes it a little challenging for users who have to know the names of screening libraries and visualization scripts. And they have to be careful that they specifically follow the help documentation. So what we could do is provide in the user interface some feedback to the user about the inputs that they're providing. So yeah, so for the target ID, it has a minimum length, a maximum length, and only certain characters are allowed. And then for the screening libraries and visualization scripts, it only accepts specific values. So for example, one of the allowed values for screening libraries is screen_drug bank. And so we don't want to have to force our users to memorize all these different special values. So what we'll do is for the first input, target ID, we'll add some validation logic. For the second one, the target structure, we're just going to leave that alone for now. We're not going to customize that at all. For the third and the fourth inputs, the screening libraries and visualization scripts, we're going to provide some label checkboxes for the user to select. Okay, so let's go back to the portal, and we'll go back to the settings. I'll click on settings, and it's going to ask me because I have an experiment here that I haven't saved. I'm just going to say leave page. I'm okay. I don't want to save that. And scroll down to my eFind site, and I'm going to go back to the interface tab. Okay, so for target ID, which is our first input, there's this box down here called Advanced Input Field Modification Metadata. So this is where we can customize our application input. And what I'm going to do is, oops, I can just click this button here to copy this. This is JSON configuration. And I'll paste that in here. And I guess I should explain what this is doing. So one of the configurations that you can specify is an array of validations. And so this shows off the 3 different types of validations. They're pretty simple. There's a minimum length one, a maximum length one, and you can also specify a regular expression. You can customize what sort of message gets displayed to the user when that validation fails. So for this one, it says target ID may only contain alphanumeric characters and underscores. Okay, so we've applied that one there. Let's, yeah, it should look something like this. Yeah, there should be, it should be outlined in green, and you should have a little green check mark. That means it's valid and you didn't miss part of it. So, I mean, hopefully you clicked on copy to clipboard and it just copied everything. Okay, right, and I explained that. And we specified the, oh yeah, so the other thing is we specify the UI component to use for this input. And we said use the string input editor. That's the default. That's actually the default UI component. That's what it's been using, but we went ahead and specified that. Okay, so now, important thing here is to skip past target structure. We're not going to customize that one. So that's our second one. We'll skip past that one and go down to our third one, which is screening libraries. And for this one, same sort of thing here. We're going to click copy to clipboard and then paste that into the advanced input field modification metadata. And then got our green check mark. That's happy. So what this one is doing is it's saying, okay, for the UI component to use, instead of this string input editor, which is the text input, use checkboxes. And we configure it by specifying an array of options that are available for this checkbox input editor. And the options, for each option, we have some text, and then the actual value. Oh, here's our drug bank one. The value is what will go into the job script on the command line. The text here is just, essentially what gets displayed to the user. So that's nice. You can have, you have some special value that your application code knows what to do with, but you can be a bit more descriptive in the text of the option for the user to kind of help explain what it is. Okay, and then let's scroll on down to visualization scripts. And we'll copy this one. And this is very similar to the screening libraries. It's again checkboxes, and we've got some option and an array of options. Okay, so that's it. And what we can do now is just click Save down here at the bottom of the screen. Okay, it's saved. Now we can go back to the workspace, back to our dashboard, scroll down to our eFindSight application. Okay, so it looks a little, so these look different. So now we've got checkboxes here for screening libraries and visualization scripts. For target ID, I didn't test this before, but for target ID now, if I don't have anything in here, it'll say this field's required. It's got to be at least 3 characters in length, and you've got to, and it can only contain alphanumeric characters and underscores. So if I start typing ABC, okay, so now I've satisfied everything. I have a value. It's 3 characters. It's all alphanumeric. If I add an invalid value, then it tells me what's wrong about that value. And if I keep going here in the alphabet, eventually, once I get more than 10 characters in length, it'll let me know that I failed that validation as well. So that's the validations. And then the checkboxes, I can check multiple values here. And then these values will be added to the command line. And by default, they get added as comma separated values when you have multiple values. So it's kind of up to the application code to be able to handle that, or that can be customized too. Okay, so that's that part of the tutorial. Let's see if there's anything else to say there. So we have other UI components available. There's text area, radio buttons. You can do a drop down. Drop down's useful so radio buttons are useful when you have a single option the user can pick and you don't have very many. If you have a lot of options, you might want to use a drop down. Yeah, and then another thing, so we're working on a couple of different ways to define custom input editors. So we're hoping to be able to incorporate that. And another thing that we didn't cover in the tutorial is you can define dependencies between different inputs. So you can say only show the second input if the first input has a particular value or something. And that can be useful for creating kind of menus that guide the user through the different options that are available. Okay, I'm going to flip back to the tutorial. Let me check the time. Okay, so it's almost 6. So I think we're right on time. Okay, so we're going to take, in a few minutes here, we'll take a 30-minute break. So during this break, I think, we'll be around to help with getting some of these prerequisites installed. So again, if you don't have Python, if you don't have Git, or if you don't have Docker Desktop, and if you're having trouble getting those installed, we'll be around during this break period to help with that. Let's see. Okay. Yeah, so I think that's it for the first part of the tutorial. Are there any questions? Okay, if there are no questions, then I think we can go ahead and break now. So the conference time it's almost 6 o'clock, and we'll come back at 6:30. So we'll be back here. We'll start again at 6:30, and I'll be back in a little bit. I'm going to go grab something to eat, and there'll probably be some of us around if you have any questions about getting those prerequisites installed. Because in the second half of the tutorial, we're going to run a local Airavata Django Portal instance using Docker, and we'll do some code development. So, okay, Arima, is there anything I'm forgetting or?
No, Marcus. I think we are good. I think we'll break and we'll go to we'll come back and take from there. I think we are good.
Okay.
Yeah.
Thank you everyone for the first part of the presentation. See you in half an hour then.
Okay.
Thank you.
Thank you. Okay, so I think we'll go ahead and get started. Let's see. Let me go ahead and share my screen. Okay. So let's see. Next part of our tutorial is creating a custom output viewer. Let's go over here. So let me see what. Yeah, okay, so we've got 3 steps in this exercise. We're going to run a local instance of the Django portal on our own computers using Docker, so we can develop some custom code. And then we'll set up and create a custom output viewer package and install it, and then we'll develop and integrate this Gaussian eigenvalues view output view provider. So let's go to the tutorial. So I'm assuming that you have Docker and Python and Git installed. Let's go down here. So I'll put this link in the chat. This is the part of the tutorial we're in. Okay, so yeah, by default, the Django Portal provides a simple way to look at output files, which is that users can download them to their local machine, and then they can do whatever they want on their local machine. But you might want to provide ways to visualize or analyze those files within the portal itself. So what we're going to do is, the first step is we're going to create a custom Django app, which we'll use in the next part of the tutorial, but we're creating it now because it sets up the Python package in which we'll write our custom output view provider. So let's see. So what the first thing we need to do is create a Python virtual environment. Now, all of these instructions here assume that everything basically happens within the home directory. Technically, you don't have to do this all within the home directory. But if you decide to follow these instructions in a different directory than your home directory, you'll have to make that substitution as you go through this. Okay, so let me go to my terminal and make sure I'm in the home directory. And I'm going to create a Python virtual environment. And so I'm just making sure that I'm using Python 3.9 to create this virtual environment. And I'm naming it tutorial-env. Okay, and now I'm going to activate the environment. Okay, and I know that it's activated because it's added to my command prompt in parentheses the name of the virtual environment. And there are instructions for it. It's slightly different on Windows. So we're going to use a tool called Cookie Cutter. Yeah, Cookie Cutter is a tool that can generate source code for a project from a template. So we have a template set up for creating these custom Django apps and the custom output view providers. And so we'll make use of that. So we have our virtual environment activated. What I'm going to do is install Cookie Cutter into that virtual environment, like so. And that happened very fast for me. It may take you a little bit longer because I think for me, a lot of this is cached. Okay, so now we've got it installed and we can use it to create our custom Django app. So there's this repository that I created with a Cookie Cutter template for a custom Django app. And that's what we're doing now. We'll run Cookie Cutter and give it that repository as the argument. And so it's you probably won't see this unless you've gone through this before. So I've previously downloaded this template and it's asking if it's okay to re-download. So I'll just hit yes. I'll just hit return. Okay, so as far as the name goes, let's see. So the way Cookie Cutter works is it asks you a bunch of questions and you answer them. And based on your answers, it generates a project source code. And most of these questions it asks, it has a default value. We're going to take the default value for everything except for the first question, which is project name. And for the tutorial, we'll call it custom UI tutorial app. So I'm just going to copy that and paste that in here where it's asking me the project name. And then it takes that project name and, you know, removes spaces, and it makes it into converts it into a proper Python package name, essentially. And we'll just accept that. And the description will accept that. Yeah, so all those defaults, we'll just hit enter and accept all those defaults. Okay, so that created our Django app code. Now what I'm going to do is I'll load this up in Visual Studio Code. Well, let me show you first. So it created this directory, custom UI tutorial app, and then all the files within it. And so to take a closer look at that, I'm going to open that up in Visual Studio Code. Okay, let's just expand all this. Okay, so it created a Django app. And we'll take a look at this a bit more in the next step. Let me go back to the instructions. Okay. So now that we've got our custom Django app set up and ready to start developing, now we're going to set up our local Django Portal environment in which we'll develop and run our custom code. So we're going to use Docker. We also have instructions on running the local Django Portal development environment as just using Python directly. And that's actually what we recommend if you're doing real development of a custom Django app. For the tutorial, it's much more, it's much easier to just run everything in a Docker container, so we don't have to deal with dependency issues, which can take a while to resolve within a tutorial setting. But for real custom Django app development, we do recommend using Python, because then you end up having all of the Airavata Django Portal source code right there. It's easier to debug things when things don't work. It's easier to look at the Airavata Django Portal code to see how things are working. So there are tabs here for just using Python. But for the tutorial, we're going to use Docker. The first step we need to do before we get into the Docker steps are we need to get a config file for our local development environment. This config file will allow us to log in to our local development environment just like we do on Test Drive, and it'll allow our local development environment to connect to the Airavata API server. So what you can do is you can just open this link up into a new tab. And if you need to log in, you can log in. I need to log in. And this takes you to the developer console. So this is under settings. This is one of the, if you go to settings on the side navigation, it's this last option here. So the developer console gives you a way to download a config file, what we call the settings local.py file. that you use for local development. So I'm just going to click download, and I'll save that file. Okay. And now what I want to do, and there are multiple ways of doing this, but what I want to do is, let me go to my home directory and my custom UI tutorial app directory. And I want to put the settings local.py file into that directory. Okay, so now if I go back to the terminal, if I list the files on my custom UI tutorial app directory, now I should see settings local.py right next to these setup files and README, etc. Okay, so now I've got this config file. So now we can go ahead and start things up. Okay, so for Docker, all of these commands should work on Windows, but the assumption is that you're using PowerShell. Okay, so assuming that you have Docker installed, what we'll do now is we'll create a Docker container called custom UI tutorial. Okay, so first thing I'm going to do is change into, let me get over to my terminal, change over into the custom UI tutorial app directory. And again, there should be, I should see that settings local.py file in that directory. And then I'm going to run this Docker command. It's a little long. Let me go ahead and start that, and I'll explain what's going on here. So this one, yeah, so it started up pretty quickly for me because I already have it downloaded. I already have this Airavata Django Portal image downloaded. And what it's doing is it's mounting that settings local.py file into the Docker container. So this Docker container will use that settings local.py file as the config file. It's also mounting the current directory into /extensions. So that way we can, all of our custom code we're creating is mounted into the Docker container, and we can install it into the Docker container's virtual environment. And it's exposing the Django Portal's port on port 8000. Here's where we name it, and it runs in the background. And then we want to make sure we're always pulling the latest version of the image. Okay, so there, that got that guy running. So now I'm going to open up, let me open a new tab here. So what I'll see, once it starts up and is running, you'll see when you go to localhost 8000, you'll see welcome to your new Wagtail site. Now, Wagtail is a content management system that we use for the home page and the other public pages of the Airavata Django Portal. So it's a pretty easy way for you to go in and use an editor to customize the home page and sorted public pages of your Science Gateway, which we're not going to talk about that much in this tutorial, but there is other information on the on our website about how to use that. So this is what you get with Wagtail by default. So what we would want to do now is load. We've got a default set of CMS pages that we can load, and it kind of gives us a good starting point. So what we'll do is run this command now from the terminal. So this runs a command to load a set of default pages, and you should see new default theme is loaded successfully. And then if we go back to localhost 8000 and refresh the page, now we see the these default set of pages. And there's kind of stock images and placeholder text and things. But what's nice about this is you can go in and start customizing these things and making them, make it your own with your Science Gateway. But now that we've got these pages loaded, now we have some links here, like the login link. So we can click on that. And now I'm going to log in. Log in. Well, I'll log in with CI log on. Click that. Log in with my IU credentials. And now I'm logged in. And so this looks an awful lot like, and it essentially is the same as logging in through test drive. So I see all the experiments and things I've created. We can see the eFindSight applications we created, etc. So that's good. It's working well. Okay, so we've created our custom Django app, which is a Python package. And we haven't really done anything with it yet, but we've also set up this local development environment. Now what we want to do is create our custom output viewer. So we've got another cookie cutter for that. So to start with, I'm going to go back to my terminal and go into the custom UI tutorial app directory, which I'm already there. You probably are too. So I'm just gonna, oops. Yeah, I'm already there. I'll go ahead and run this anyways, just to double check. But you want to make sure that you have your tutorial environment, virtual environment activated. And so if that's true, then you should be good to go to run the cookie cutter template in step 2. And this will be similar to the other cookie cutter template. So is it okay to delete and read out? You probably won't see this, but. Okay, so there are 2 things we'll change here. And we'll take the defaults for everything else, but the project name, we want to call it Gaussian Eigenvalues View. Okay. And then we'll accept for the project slug, we'll accept that default description, we'll accept that class name, we'll accept that. Okay, now the custom Django app module name. This is where we need to let this cookie cutter template know what is the name of the Python package for the custom Django app. And the way we created it, the name is for the Python package is custom _UI _tutorial _app. So I'm just going to copy that, paste that in there. The directory name is output views. Yeah. So we have a few options here, and depending on what type of output view provider we want to create. And this one is going to be an image one, so we'll just accept the default. And the code's slightly different that gets generated whether you're dealing with a single file output or a multiple file output. But again, this is a single file output, so we'll just take the default there. Okay, so that created. So now I'm going to flip over to my code editor. And I should see in this output views folder, it generated this Gaussian eigenvalues view.py file. So this file, so what's nice is it generated all the code, kind of the code skeleton. I've got to fill out the implementation. It does have some sample code. For example, like how would you read in the file? We have a user storage module that allows you to query and manipulate the user's files. Sometimes you need to access more than just that single file, single output file. You can also make, from here, you can make requests to the Airavata API, and there's documentation and sample code on how to do that. And then there's information on, there's sample code on how you create the proper return value for this output view provider. Okay, before we get into that, so we just have generated code now. What I want to do is kind of motivate what we're doing here by changing over to a Jupyter notebook. Let me switch over here. So I've got one running over here. So I created this notebook to kind of show how you might come up with one of these output views. So the way it's designed is, if you have some Python code that can generate, in this case, an image, some sort of image visualization or chart or whatever from an output file, then that should be fairly easy to incorporate into the Airavata Django portal as a custom output view provider. So here I have, let's see, where's the, yes, I've got this log file. Yeah, so I've got this log file in my Jupyter notebook server. And what I'm doing here is I'm installing some libraries I need. CClib is a computational chemistry library that has utilities for reading Gaussian log files. And then NumPy and Matplotlib are kind of standard ways of doing some plotting of data. Here I'm setting it up just to display Matplotlib figures inline. Got some imports here, some different classes I need from these libraries. So my first step is to read this log file. And then I'm going to parse the output file. So this is where I take the output file and I run CCopen on it, and CCopen's from CClib. It's going to read in the Gaussian log file, parse it, and then I get some data out of this Gaussian log file, and I start gathering up these molecular orbital energies. So I get all that data collected up. And then down here, I'm creating a Matplotlib figure. So this is just, pretty much standard Matplotlib stuff. I've got 2 subplots here, and I'm just putting the values in here and labeling them, etc. And in this notebook cell, I return the figure, and so it just displays inline. So I've got, so the idea is that, let's say I have a notebook. Sorry, let me start back. Let's say I have an application code. It generates some output file or output files. And I have a Jupyter notebook or some other, I mean, it doesn't have to be a notebook, but I have some sort of Python script that can generate some sort of visualization of that data. Then what I can do is pretty easily take this code and copy it into that skeleton code that we just generated. So here, let me go back to the tutorial. So what we'll do, let's see, step 4 here. So what we'll do is we'll just copy the whole thing. This is the Gaussian eigenvalues view.py file. We'll copy the whole thing and paste that in, and then take a look at it line by line. So I'm just going to select all and then paste in that code. Okay. So I've got these. Okay, so then we'll go through this. Let's see. Go through this line by line. I've got some imports. So the skeleton code had its own imports, and what I've done is I've added in those imports I needed, like NumPy, cclib, matplotlib. I added those imports in there. And then in generate data, I basically have this code here, like I had in my notebook. So I've got the imports. So I've got this code here for parsing the output file. So that's what this is doing, same code. And then I've got some code here to create the figure. Create this plot. Okay, so that's the same code. What's now different, so the thing that I need to do differently is the Jupyter Notebook knows how to display a matplotlib figure just directly, like you just return the figure and as the output of a cell, and it will just display it in line. I need to do a little bit more in my custom output view provider. So what I'm going to do is save this figure into an in-memory buffer, and then get the value of that buffer as an array of bytes. And then because that's what I need to return. So this output view provider needs to return 2 things. It needs to return the image as an array of bytes, and it needs to return the MIME type of the image. So this one's a PNG image, but if it was a JPEG or a TIFF or whatever, then you have to return the appropriate MIME type. So yeah, so that's basically it as far as implementing this output view provider, filling in that skeleton code, which can be as simple as copying the code you have from some notebook that maybe you already have this laying around, a notebook that generates this output view. Okay, so let's go back to the tutorial. I think, let me see if there's anything else I wanted to cover there. Okay, so I think that's it for the code. So there's a couple other things that we need to do. One thing has already been done, but we'll take a look at it. So if we go to setup.config in our code. So for an output view provider, so the Airavata Django Portal needs a way of discovering the output view providers that you have in your Python package. And the way we do that is we use this Python packaging mechanism called entry points. So we've defined an entry point called Airavata.OutputViewProviders, which is then a list. And so you have a label or an alias, and we'll see where that gets used for your output view provider. And then the Python module and the name of the class of your output view provider. Now, our cookie cutter template, it not only generated this Gaussian eigenvalues view.py file, it also updated our setup.config file and added and registered our output view provider entry point. So we don't have to do anything here as long as we're using that cookie cutter. Okay. And okay, so while we're in here, let's look at setup.config. So one of the things I had in my, one of the things I had in my notebook to get it to work is I had to install some additional dependencies. Right. So the way we accomplish the same sort of thing in for this custom output view providers, we declare those as dependencies of our Python package. So I'm going to copy this, and we'll go over and take a look at it. So in setup.config, by default, it requires Django and the Airavata Django Portal SDK. And what we're going to do is, let me paste that in there and get rid of these extra lines. And so what we're adding then is cclib, numpy, and matplotlib. So when anybody installs this custom Django app, which again is a Python package, into the Airavata Django Portal's virtual environment, it will take care of installing any of these dependencies. Okay, so that should be it here. Okay, so now we have the code. We've written the code. The code is mounted into our Docker container. If you remember from when we created the Docker container, we mounted our custom code directory to /extensions. So now what we can do is run a couple of Docker commands to install our custom Django app code into the Docker container's virtual environment. So let me go back to my terminal, run this. And you'll see, so now it's installing our dependencies, cclib, numpy, matplotlib. So it installed those, and now it's adding in the custom UI tutorial app. Okay. And then this second command here is it's just a mechanism for triggering a reload of a Django server. So we'll run this guy, just touching the whiskey.py file. And that should do it. Okay, so let me go back to the portal. So we'll go to localhost 8000, and I'm already logged in, but if you're not logged in, log back in. And we'll go to settings. Okay, and we'll find Gaussian 16. Now we're not actually going to do anything here, but we are going to just verify that our output view provider is registered. So let's see, let's go to the interface tab. And if we go down to our output file, this Gaussian application output. Under metadata, we should see, we've got a JSON configuration here. There's an output view providers config property, and you specify the value as an array of output view providers. And there's just this one, this Gaussian eigenvalues view. And so that this name here is basically that alias that we provided, or that's specified in the entry points in setup.config. So that's where that alias gets used. We specify that. So that means that output view provider, if it's installed in that Django Portal instance, it will be used, or it'll be, we'll see. There's a menu where you can select it as an output view of that file. So let's go back to the workspace, and I'll find, so here's my Gaussian 16 run that I did earlier. Click on that. It's taking a little while to load. There we go. Okay, so here's my Gaussian output. Here are all the output files that Gaussian produced. Actually, there are more files because we bring back the entire directory in this archive folder. But here are the ones that were registered. And so for each of these, I can click on these files and download them, or just view their output right here in the portal. But for Gaussian application output, you can see I've got this menu over here. So there's a default view, which is just downloading the file, but I can also select that custom output view that we just created. And when I select that, what it does, the Airavata Django Portal will call your output view provider code, pass this output file to your generate data function, and then the generate data function creates this matplotlib figure, saves it to an image as a byte array, and then the portal then takes that byte array and returns it as an image to the browser and displays it. So let's see. So that's creating a custom output view provider. Look at the, we're just right on time for the agenda. The other thing I will say here, we don't really have time to do this, but if you want to, you can play around with interactive parameters. So the output view providers support interactive parameters, which are ways to add some interactivity to it. So in this example, this one's pretty simple, but here you add a Boolean parameter called showGrid. It renders as a checkbox, and when you click the checkbox, showGrid then gets passed to your generate data function. You can use that to draw grid lines. The user can uncheck it, and then the grid lines disappear, etc. And so you can do lots of different things with that, and it's pretty simple. There's basically 3 steps here. You add your parameter as an extra argument to your generate data function. You use that value. So here, this is using showGrid to display the grid in Matplotlib's API. And then when you return, so we saw before, your generate data function, it needs to return, for images, it needs to return an array of image bytes and the MIME type. So if you're doing interactive parameters, you also return this interactive key with a list of names and values of the different interactive parameters. And that's essentially it. And the let's see, there's additional documentation here on the different things you can do with that. So there's the Boolean argument type, which gets rendered as a checkbox. Strings get rendered as a text input. Number types get rendered as either a stepper, or if you have a min and a max, you get a range slider rendered. And you can also define a list of options, and that'll get rendered as a drop-down select. So there's a few different things you can do there with interactive parameters. But yeah, so that's kind of that's something to play with outside of the tutorial. Okay, so let me see here. We're doing pretty well on time. Okay, so the next thing is we're going to develop a custom Django app. We've already generated the skeleton code, and now we just need to add the implementation. So we're going to do something that's like pretty simple, but we're keeping the example simple so that we can focus on the mechanics of using Django APIs and the Airavata API to build a custom user interface. So what we're going to do is create a user interface that allows someone to pick a greeting in one of several languages. We'll develop our own REST API to provide all these different options. We'll submit a job to a batch scheduler to run a simple echo type job. And then we'll read in the output files and display them in the page. Okay. Yeah, so I think I've already covered this, but there's some links here to documentation on Django apps or applications. It's kind of a plugin framework inside of the Django web framework. And so that's how we're going to be integrating our custom user interface. Okay, so let's get going here. So we're just going to create a simple Hello World page and get it properly set up with our local Django Portal instance. So if we could, what we can do is we can go over here, and because we've already installed the custom Django app, if I click on my workspace menu at the top, I now see this new option down here called Custom UI Tutorial App. That's what we generated. So this is kind of what you get with just the auto-generated code, just a welcome page and a basic icon. But we'll customize this stuff now. So what I'm going to do is, let's see. So let's go back to our code editor. Yeah, let me close up some of this stuff. So in my custom UI tutorial app, I have a templates folder, and inside that custom UI tutorial app, and inside that home. So this home has this welcome to the name of the project from auto-generated code. It's got some example code in there, so you might want to take a look at this later. So let's not edit that one directly. What we're going to do is copy this file. So I'm going to Command C, Command V, copy and paste that, and I'm going to rename it to hello.html. So I just created a copy of home.html to hello.html. And I'm going to change the title of the page. So there's this H1 tag here, line 9. So instead of welcome to project name, I'm going to change that to hello world. Then I'm going to add a view that renders this hello world template. So now what I want to do is go to the views.py. And I guess I should mention a little bit about the structure here. So in a Django app, the standard files that you have are, you have a, well, let's see, I'll start from the top, I guess. So you have an admin.py, this one's empty, but you can use that to integrate with the Django admin interface, which we don't typically do. The apps.py file is kind of the entry point of your Django app. And so that's where we put a bunch of configuration for the app. And we'll take a look at how to change how this is configured. Models is where you add your database models. So you can have your own custom database models for any sort of additional data that you want to save. You might have data in your custom Django app that you want to save that is kind of doesn't fit within the Airavata data model. And so that's where you would define that. Test.py is where you can add unit tests. I'll skip over URLs. Views is where you add view functions. So that's this Python code that takes an HTTP request and returns an HTTP response. And then URLs.py is where you map URLs to those view functions. Like you can see, home is mapped to views.home. So that's why when you go to the app, where was that? Yeah, when you go to the app/home, it maps to rendering a view function that renders this template. And yeah, and at the top level, you have various Python packaging files, really. But yeah, so those are the main, and then the templates, you have templates, Django templates, static directory where you can add images, CSS, any other sort of static files. So that's the basic structure of it. So now that we've got our hello.html template, again, we're going to add a view function down here in views.py. So I'm going to click on copy to clipboard to copy this hello world function and paste that in there. And then I want to add a mapping in urls.py. I want to add a mapping of the hello URL to this hello world view function. So I'll copy that, and I'll just Control A to select all, and just paste that into urls.py. Okay. And then in apps.py, we've got, again, this is where we kind of configure things like the name of the app, the URL that's the home page for the app. So if you just go to the app, which URL do you go to? And the icon, we use this library called Font Awesome for all the different icons. So for this one, I'm going to customize all these. Whoops, let me just click copy to clipboard, and I'll just paste that in here. So we've changed the icon class to be this comment, speech bubble type icon. And we've changed the home page to be this hello world view that we just added. Okay, so that's that. So now we can go back here. I'm going to reload this page. I go down here, I click on my custom UI tutorial app from the menu. The home page is now this hello world template. And you can see that the icon associated with this app is now this speech bubble. Okay. So we're in there. Yeah. Okay, so that's okay, so we got that all set up. Okay, so now we're going to add our list of hello greetings that the user can select. So what we want to do is create a REST endpoint that will return greetings in several languages. So I'm going to click on
Marcus.
Yeah.
A quick question about that the symbol, I mean the speech bubble, can it be also customized?
Yeah, it can be custom. Yeah, that's what we just did. So
this font awesome, class. I mean, so it is something that is a library that was loaded, where from you get this font awesome circle or the other one.
Right. Yeah, and so in the generated code, there's a URL to the Font Awesome library, or sorry, the website, and it shows you all the different icons.
So that is the Font Awesome library. So if I want to have my own image, how is it possible?
If you want to have something, you want to have an icon that's not a Font Awesome icon?
Yeah.
No, we don't support that.
Okay.
But Font Awesome has over 1,000 icons.
Okay.
But I mean, that's so like if you wanted to find a different icon, that's where you would you can come here and search for them, like the comment one. So it's this one here, and so that's, and so once you get the name, right, once you get the name, you can see that you change this to FA comment. Oops, doing that. Yeah, so yeah, you can search for, I mean, we could change it to comments. So yeah, there's just lots of options there.
Okay, thanks.
Yeah. Okay. Yeah, so let's add this REST endpoint. So we'll go to views.py. Views.py. So we need to add an additional import because we're going to create a JSON response. Okay, I'm going to add these extra lines. So I'm going to remove the extra lines. So we've imported JSON response. And now I'm going to add a view function. So I'm going to copy this one and add this to the end of views.py. Okay, so this is a languages view function. It returns a simple JSON response. I mean, this one's static, but it, you know, obviously these don't have to be static responses. So it returns well, we'll take a look at this in the browser, but it's a list of languages and greetings in each of those languages. Let's see. So now we need to add a mapping to this view function, a URL mapping. So I'm going to copy these URL mappings and go to urls.py. I'm going to select all and paste that in. So we've added this languages URL mapping to the languages view function. Okay, so now we need to display these in our page, and well, we need to load them via a REST API call and then display them in the page. So let's go to hello.html. And in there, what we want to do is right under the H1 tag, we want to add this code here. We'll create a card with a select element that will list out our languages. So I'm going to copy just that bit and go in here and under H1, paste that in. Okay. And then, okay, so that's where it will display. Now we need to load it in. Okay, so now what we want to do is in our JavaScript API, we have fetch utils, just a handy wrapper, really a wrapper around the native fetch function to call REST APIs. So we'll use that to call our languages view function and get the data, and then for each of those languages, we'll append an option to our select element. So I'll copy that bit and we'll add that here. I could, actually, I'll just put it up here. Script tag. Okay, so this code will just, so this is inside of a JavaScript script tag. It'll just run automatically when the page loads. And so that should, I think that's it now. So yeah, so go back to localhost, reload the page. Okay, let's see. Let me do that one more time. Okay, so that loaded up and then it called our REST API. And the response was, yeah, some JSON, an array with a bunch of languages and greetings in those languages. And then we populated this select element with that data. Okay. Okay, so we've got that part done. Next, we're going to use the Airavata API to load a list of recent experiments. So what we want to do is add another card to our page. This one will have a table with a row for each experiment in the list. And there will be a refresh button, which can't remember if we hooked that up in this part or not. But anyways, let's add that table. So I'll copy just that part there. And let me go over here. And so right under the card that displays the list of languages, we're going to add another card to display our experiments. Okay, then if I go step 2 here, okay, so we've got in the Airavata API, there's an experiment search API, and we have a REST wrapper around that and JavaScript code to make it easier to work with, called the experiment search service. And so what we're going to do is load the user's most recent 5 echo experiments and display them in this table. So I'm going to copy this code and we'll add this in our scripts block down here. So we'll just add it after that code we have for loading languages. And what this is doing is, let's see. I don't think I have that in there. Let's see. So it's calling the experiment search service. It's limiting it to 5. So it's got a paginated API, so we can limit or have offsets into the list of experiments to return. And then we have some additional filters that we apply. One is, so we have all these different search fields we can use that are available on this experiment search fields object. So one is the name, the user's name, the username of the user that created the experiment. And we can get the username of the currently logged in user from the session object. So this will, this is how we filter to just experiments that were created by the currently logged in user. And this is how we filter by experiments that were created from the application interface for Echo. And I'll explain a little bit later how I got this ID, but this is the ID in Airavata, in the Airavata API for the application interface for Echo. So this loads this data from the Airavata API. And then this is just some jQuery to empty out the rows of the table and then go through and add the rows of the table for each of the experiments that got returned by the search service. So what we'll do is we'll run this load experiments function when the page loads, but then also if the user clicks on the refresh button, we'll load the experiments. Let me go back here. So that should do that. Let's see. I save everything. Save that. Okay. So if I go back to localhost and refresh the page, I should see it'll list out all these echo runs that I've done. And I can click refresh and it will, refresh that. There's nothing different yet. Okay, so let me go back to the tutorial. Okay, so now we can display experiments, these echo jobs. Now what we're going to do is actually submit an echo experiment and hook up that run button. Okay, so what we need now are some functions to handle clicking the run button and submitting the experiment. So let's copy those and add those to at the bottom of the script tag. So here's our function. Let me see if what I've got in here. Yeah, so let's look at this line by line. We'll kind of start at the bottom and go up. Save that. So we added a click handler for the run button. So when the run button is clicked, it's going to run this function, run click handler. This gets the value that the user selected for the greeting, and then it calls submit experiment. And when that finishes, it's going to reload the list of experiments. So when we click run, it should submit the experiment, reload the table, and we should see it listed in the table. And then submit experiment. It's going to take the greeting, and so we have this utility called experiment utils. Has a couple of utility functions we'll look at. One is for creating an experiment. So what we do is we pass it the application interface ID, and we also give it the name of the compute resource we want to run on, the name of the experiment. Here, what I have it doing is just echo plus the greeting, and the inputs to the experiment. So the echo experiment, actually, let's take a look at that real fast. So echo has one input, and it's named input echo. So the name's pretty important. For the experiment inputs, we give the name of the input and the value. So yeah, so that's all we need to do to create an experiment object. This isn't saved yet. We've just created an experiment object, and then we'll use the experiment service to create the experiment object and save it, and then we'll use the experiment service to launch the experiment. And again, these are the experiment service is a JavaScript wrapper around the REST API, around making calls to the REST API, which in turn is proxying to the Airavata API. And I also wanted to say, okay, so I was going to tell you where I got that ID for the application interface. So in the REST API, one nice thing about the REST API is it's browsable. So what we can do is go to, actually, let's go to the API root. So the REST API, and this is not exhaustive, but most of the REST APIs are browsable from this root, and so here you can see, we could look at the projects that the user has access to, experiments. This is the search API, etc. And what we're going to look at is the applications REST API. Okay, and the first one is echo. And what we need, so in the Airavata API, an application that's really a module, which is essentially metadata about the application, an interface, and a deployment, or multiple deployments. So for this echo application, what we need is the ID of the interface to be able to create an experiment from it. So I'll click on this application interface link. that takes me to the application interface for that module. And here's where I can get the application interface ID. So that is where is it? Yeah, that's where this comes from. So you can, yeah, so you can use the browsable REST API to find a lot of these different IDs when you're developing this code. Or I mean, obviously you can also make a user interface where users are picking applications, or you can look up what's the ID for the Echo application. But here, kind of making things a little bit simpler by just hard coding some of these values. Okay, let me go back to the tutorial. Yeah, there's a lot that this experiment utils create experiment is doing, and there's some information on different things it's looking up so it can create a proper experiment object, mostly around looking up information about the compute resource, making sure that the application's actually deployed there, getting the default queue settings, etc. And yeah, so we talked about this, creating and saving and launching the experiment. Okay, so that should work now. Let me make sure I saved everything. So let me go back to localhost. I'm going to reload the page. Okay, so let me try. I'll select Konnichiwa and click run. I should have opened up the inspector. Okay, it refreshed the page, and you can see that it's created this Echo Konnichiwa experiment. Didn't get that in time. Let's see. Oh, let me do one more. We can see what the REST API looks like. Let's try Turkish this time. Merhaba. So I'll run this one. Okay, so you can kind of see that a little bit behind the scenes, the experiment utils is looking up some things. So it's looking up the application interface so they can create an experiment from it. Oops. It's looking up the names. It's looking up the ID for the compute resource that we specify. It's trying to find a group resource profile, which is what we call the application, or sorry, the allocation to charge the job to. It's looking up that to find one that can be used for this experiment, and then it's looking up the deployments, etc. But then we get to our part where we save the experiment. So here's the request. So this is the, I don't know how nice that would be. The raw, it's kind of hard to read. But this is JSON. Here's all the information, or here are all the details of the experiment object that we created. And so, the first input has this value, Merhaba, the name, standard out, standard error for the outputs, etc. So it has all these, it's figured out the queue, the resource, the compute resource ID, etc. So we've saved that, and then we call launch, which is pretty simple, and it just returned true because it was or success true. And then the experiment list was reloaded. Okay, so now what we want to do is get the output that was generated and displayed in the page. And so this is really basic you can imagine doing things much more interesting with the output files generated in a real custom Django app. But this will show how you can, from JavaScript, you can load the output file of an experiment. And so what we need to do is, in our code, where we fetch the experiments and we display their results in the table, what we're going to do is check to see if the experiment is completed. And if so, we're going to fetch the experiment data object, which will have we'll fetch the experiment data object. We'll have information about all the outputs, like the ID of the output files. And so that's what we're doing here. And once we have that ID, which is called in Airavata API, it's called a data product URI. That's an identifier for a data product or file. Then we'll read it in and display it into the table. So let me see. I'm going to go down here. So in our loop, where we loop over each result in our in the results from the experiment search service, and we go row by row for each of those experiments, we're going to add in this bit of code here. So I'm going to click this to copy all that. So in here, wait, where did it go? Oh, there it is. Okay, so right after these lines here where we create a table row, add the code there. That's not quite indented correctly. Do that. Okay, so this is adding a row for the experiment. And then if it's completed, it's fetching the experiment data object, figuring out, it's getting the, this should say output, not input. It's finding the experiment output object named echo standard out, and then getting its value, which is a data product URI. And then we'll read that in, and if it's null, then that means that the file wasn't found, which sometimes happens when, because data retention policies and what have you. But if it finds it, it'll add it to our table. So let me save that, and I'll go back to the web, back to localhost. And let me reload this page. And there we go. So yeah, my Echo Maraba finished running, and it grabbed the output from the standard out and plopped it into the page there. And you can see where it's. So a few of these it didn't find, or the file's no longer existing. So it returns 404 not found for some of these. Yeah, but so 3 of these are returned the value. Oops. Yeah, anyways. So it downloaded the file by this data product URI. The response is encoded. So that's it. That's the custom Django app tutorial. So the rest of this here at the end of the tutorial, there's information about you can get to the, if you had any issues with the getting the tutorial to work, or you just want to make sure that your code, your tutorial code matches the final version, you can look at the final version here. The final version is deployed in test drive. So if I go back over to test drive, you can play around with it here in test drive. Yeah, so we've got information on the Django Portal REST API, the Airavata API, and then the JavaScript library. You can look at the code there to see what's available and how to use it. So we've got a few more minutes, and I was going to get back to the slides. Let me see. I guess what I'll say at the end. So I talked a little bit about this SimCCS custom Django app that we've been working on, where users are able to pick carbon dioxide sources and sinks and set up a optimization problem to solve. And here we have different case studies that they can load, and they can edit those and run them, select different sources and sinks, change the model parameters. They can generate, they click this generate MPS button to generate the input file, and then they can pass that into creating the experiment. And then we can also link back to the tool to visualize the output results. So just to say a little bit about that. And the way that works is we've got a custom template, a Django template that displays this leaflet map and other UI. The user selects sources and sinks, and when we pass those sources and sinks to a REST API that we defined as a view function in views.py, this view function takes those selected sources and sinks and calls a SimCCS library that we've integrated. So the SimCCS library was a pre-existing thing. It's actually a Java code. So we're using a Python to Java bridge library to call into the Java code and generate this input file. And then we use the user storage API to store that MPS file into the user's storage space and return that identifier back to the portal, step 4. And then the user can say, okay, I want to create an experiment, and we can create the experiment object and call the REST API and save and launch it just in a very similar way to what we did just now with the Echo application. So I just kind of wanted to show that as an example of how you can create, how you can use all these technologies to create a custom user interface and reuse existing codes that you have. In this case, we're creating a fairly complicated input file that would be extremely challenging for a user to do on their own, and we're using the user storage library to manage the user's storage, and the REST API to manage invoking the Airavata API. So I don't know if there are any questions. I think we're out of time now. Okay, so I think that's it. I wanted to thank everyone for attending and hanging on. And yeah, so let me see. So hopefully everyone got my email. I don't think my email's there, is it? So, there's my email, and it's also in that that Google Doc. My email, the CIRC's email, and Arima's and Marlon's. So yeah, just reach out to any of us if you're interested in exploring Apache Airavata or the Airavata Django Portal more. And I think that's it.